Hi there, this is Professor Eckhausen. I am going to talk today about operations on rational expressions. In the last video, we talked about multiplying and dividing, and today we are going to talk about adding and subtracting, which with all fractions, which is what a rational expression is, that is a little bit more difficult and requires a few more steps. So let's look at some thoughts on fractions before we begin. So in order to add two fractions, I would like you to think about what do we need to do in order to add them, and what part of the fraction do we add and what stays the same. So pause the video and give that a thought. All right, so hopefully you took a time to think about that. So in order to add two fractions, we need to have a common denominator, right? A common denominator. And that is the same with rational expressions. Okay, we need to have a common denominator. So which part of the fraction do we add and what stays the same? So if we have something like A over C plus B over C, the rule is that that gives us A plus B over C. Okay, so this is our rule for fractions. You might want to have that in your notes. It's a pretty big one. Make sure you understand that the denominator never changes. It's the numerator that adds. The denominator stays the same. Okay, so the denominator stays the same. We add the numerator. All right. So moving on, let's look at adding and subtracting a few rational expressions. So try adding that, pause the video. So every time we get to an example, remember to just pause the video and give it a try and then see if you got it right. Best way to learn. All right, so you may see that the denominator is exactly the same. So this follows the rule where we can take 5 plus 4 over that common denominator of 3x. So then when we combine the 5 and the 4, we get 9 over 3x. Now, don't stop there because it does simplify. I see a 3 in both 3 and 9. So you could do, there's a couple different ways to do this. Remember, you could say how many 3's are in 9? There are 3. How many 3's are in 3? There are 1. So that becomes 3 over 1x, or just 3 over x. Okay? Another way to think about it is to say 9 is 3 times 3 over 3x, and you can see that these 3's are going to become 1, and it is still 3x. Okay, so two different ways to think about reducing. All right, so what is the domain of this one? So it says to define the domain, define the domain. So let's just say what x can't be. So what is the one thing that x cannot be here? Well, x cannot be 0, okay, because you can't divide by 0. All right, so that is going to rule, remember, that is going to rule all of the domains for rational expressions. The denominator can't be 0. All right, so remember when we are, and I'm showing you this because this is a mistake I see all the time, and that is when we cancel, we are dividing out factors. So try simplifying these. All right, so what a lot of people will do is they'll do that and say that this equals 3/8. That is not true. You cannot divide out or cancel out anything but factors. And these are not factors, these are sums, not products. So that means they're not factors, so you can't factor them out. So this becomes 2 plus 3 is 5, and 2 plus 8 is 10. So this becomes 1/2. 5 over 10 is 1/2. Okay, so what about the next one? Try that. All right, absolutely nothing you can do with it. Okay, so do not do that. No, I'm going to erase it. Don't do that. Okay, the 3's do not divide out. So that's going to be 7x plus 3 over 5x plus 3, and there's nothing more you can do. All right, so let's move on to adding and defining the domain. So give this one a try and see what you can do with it. All right, so you will see that the denominator is the same on both of these, 3x minus 2, which means that we can just take the numerator, 5x plus 2, and put it over 3x minus 2. And like I just showed you right up here, there's nothing we can do. We can't cancel anything. So nothing simplifies. That's it. This is the final answer. So what is the domain? So remember 3x minus 2. So let's figure out the domain here. 3x minus 2 cannot equal 0. The denominator cannot equal 0. So let's just remember that this is what cannot equal 0. And it doesn't matter if you put does not equal or equal. Just remember that we're working out what the denominator can't be. All right, so I'm going to say 3x cannot equal, or you can say equal if you want to, 2. I just added 2 to both sides. Now we're going to divide by 3. And we say x cannot be 2/3. So think about it. If I put 2/3 right there, I would get 3 times 2/3 minus 2, which would give me 2 minus 2, which would be 0. So it can't be 2/3. So x cannot be 2/3. So that's our answer for the domain part of the question. All right, so let's go on to another one. Why don't you give that one a try? All right, so on this one, we've got a little bit more work to do, but not a lot. So on the top, don't let the bottom throw you. They're both the same, so take a look at them. X squared minus x minus 6, x squared minus x minus 6. They're the same. So that means we get to just combine the top. So we've got negative 3x plus negative 6x. Don't forget to put some sort of parenthesis there, or put a minus instead of a plus negative, whatever you need to do to keep track of those so they don't get lost. All right, so now the top is going to be negative 3 plus negative 6 is negative 9x over x squared. Oops, I made a mistake. What did I do? I put an x squared there. Didn't mean to. All right, x squared minus x minus 6 on the bottom has not changed. Now, does anything cancel? Can I do this? Don't write, just watch. Can I do that? No, I cannot. Don't do that. Okay, so those aren't factors. Those are part of an equation, and they're part of an expression. I'm having a hard time talking today. They're part of an expression, so you can't just take out one of the terms, right? Those aren't factors. Those are subtracted. Right, so do not cancel. All right, so we're not going to worry about the domain with this one because it would require some factoring and stuff, and I want to keep moving. All right, try this one. All right, so this one's a little bit longer. So the denominator is the same. Always check, make sure it's really truly the same, and it is. So that means we get to just combine the top, and we get 3x squared minus 34x plus, now I'm not going to use parentheses because this is a plus. If it was a minus, I would use parentheses, so I would remember to distribute. But I don't have anything to distribute, so I'm going to say plus 3x plus 10 all over 3x minus 1. All right, so let's continue on with that. And we get 3x squared. Now we're going to combine this one and this one. And what do you get? Hopefully you got negative 31x squared. Sorry, not squared. Negative 31x plus 10 over 3x minus 1. All right, so the top looks like it might factor. So maybe pause the video, see if you can figure out how to factor it. It does factor. And we get 3x minus 1 and x minus 10. And I'll just tell you something. If you see something that looks like there's a chance it could factor, maybe start by assuming that that is going to be one of the factors on the problems that you get in this class. Okay, just assume. Maybe it will be. So that'll give you a little head start on your factoring, and it will make it faster. And sure enough, that is the case on this one as well. So we get 3x minus 1 on the bottom. Now I'm going to put parentheses around it so it looks the same, right? So now it looks just like the one on the top, and you can see that 3x minus 1 is going to cancel out, and our answer is then x minus 10. Okay, so when we add those together, all we have left is x minus 10. All right, I'm not going to talk about the domain in this one, but the domain actually still is dependent upon this right here. So you'll see that in pre-calculus. All right, so let's move on to the next one. See if you can try that one. And don't forget to go ahead and define the domain this time. All right, so we get on the top 3x and then the minus 1. And oh, look on the bottom, 3x minus 1. So I get an answer of 1, right? Because everything cancels. 3x minus 1 over 3x minus 1, it cancels out. But what is the domain? So the domain is still dependent on the original question. So the domain is still where 3x minus 1 cannot equal 0. This time, instead of saying cannot equal, I'm just going to say equal. And then we'll just remember at the end that that's the one it can't be. All right, some people don't like working with the not equal. We're going to add 1 to both sides, and we get 3x equals 1. Divide by 3, and we get x equals 1/3. So the domain is where all real numbers, so you could say all reals except 1/3. Okay. The question might also say, what is the only number that is not included in the domain? So be prepared for that. All right, so let's try another one. So pause the video and give this one a try. All right, so as you see, x plus 5 is the denominator of all 3 of those. So be careful. We've got a minus and a plus. So we're going to say 9 minus 4 plus 2 all over x plus 5. All right, so we will get 9 minus 4 is 5 plus 2 is 7 over x plus 5. So our simplified version of this is that one right there. Now the domain is going to be where all real numbers except where x plus 5 equals 0. In other words, it can't be 0. So x cannot equal negative 5. Okay. So again, however you like to work with the not equal and the equal sign so that it makes sense to you. So x cannot be negative 5. So think about it. If I put a negative 5 right there, I would get 0. All right, let's try another one. Simplify and reduce to lowest terms and define the domain. All right, so once again, we have a common denominator here. So we get 13 plus 7x minus 13 all over 4x. So we get the 13s are going to subtract out. 13 minus 13 goes away. So we end up with 7x over 4x. And now what? Now what happens? Hopefully you see that the x's cancel out. X over x is just 1. So we get 7/4. All right, so for the domain, what do you think x cannot be? Look at the original here, 4x. So if you multiply 4 by 0, you would get 0. So 4x cannot equal 0 is another way to think about it if you really want to go through the whole thing, but also think about it logically, right? So x cannot equal 0. Logically, if you plugged 0 in, multiplied it times 4, you would get 0. All right, so try that one. All right, let's do it. So we've got negative 7x plus 3 on both of them. We've got a common denominator. So on top we get negative 7x minus negative 13x. And we get negative 7x plus 3 on the bottom. So be really careful with those negatives. On the top we've got negative 7x plus 13x. On the bottom, still the same. All right, so now on the top, we end up with negative 7 plus 13 because they're both x's. So I'm just thinking about the coefficients in front of them now. And I get 6x over negative 7x plus 3. All right, does anything cancel? No, there's no factors, so there's nothing to cancel. All right, so that's the final answer. And then the domain is dependent on that denominator. So the domain is going to be where negative 7x plus 3 is equal to 0. That's going to be the one thing it can't be. So negative 7x equals negative 3. I just subtracted 3 from both sides. Divide by negative 7, and I'm running out of room. Give myself a little more room here. Divide both sides by negative 7, and we're going to get x equals, what happens when we take negative 3 over negative 7? The negatives are going to cancel out, so don't forget to cancel those. And we get 3/7. All right, so that is where x cannot be 3/7. So the domain is all real numbers except for 3/7. All right, so simplify this one and reduce to lowest terms, and then define the domain. All right, so the denominator is the same on both of these. So we've got 9x minus, don't forget to put parentheses so you remember to distribute that, and then over 2x plus 3. All right, so we've got 9x minus 3x, and then what happens, remember you've got to distribute this to both of these, so we get plus 9 over 2x plus 3. So we get 6x plus 9 over 2x plus 3. All right, so we're not done here because something does factor out of the top. Okay, so we're going to look at factoring the top and see what happens. So what's the greatest common factor? So what you want to do here is on the top, find the GCF, the greatest common factor. And that is going to be a 3. So you want to take that 3 out, take the 3 out, and what are you left with? So 3 times what is 6x? Well, that's 2x. And 3 times what is 9? That's 3. All right, so that's going to be over 2x plus 3. Aha, see what happens. Now that it is a factor, those are multiplied, you can cancel those out. Oh, those were too big. We still can't see underneath there. All right, we can cancel those out. All right, so now what are we left with? We are left with just the 3. That is it. So this thing factors down to 3. All right. So remember, you can cancel out if it's a factor. You cannot cancel out if it, like at the very beginning what I showed you, you cannot cancel out if it's a sum. So factors cancel because we're working with division. All right, so try this one. All right, on the top we get, let's just combine as we go. No, let's not. Never mind. I'm going to come down here and give us a little more space. We've got 7x squared plus 5x plus 2. And the reason I didn't want to is because we have this divide and I didn't want us to mess up. So don't skip steps. You want to distribute that to that one, and to that one. So make sure you do that first. So minus 3x squared minus 5x minus 14. I'm just going to deal with the top right now instead of rewriting the bottom every time. So the bottom is just going to be x squared minus 3, right? So it's going to be all of this over x squared minus 3. All right, so let's just keep working with the top. So we get 7x minus 3x squared. So both of them are squared. We've got 4x squared. All right, so that I just dealt with that one and that one. And now I'm going to deal with the 5x's. Oh, look, those go away. So 5x minus 5x goes away. That simplifies things. And then we've got that one and that one. So now we've got plus 2 minus 14 is minus 12. All right, and that is all over x squared minus 3. So if you got that far, great. Well, you're not done. So see what else you can do with that. Pause the video if you didn't continue on from here, because that is not the answer. You need to simplify it. So take out the greatest common factor of the top. All right, so hopefully you paused the video and gave it a try. So do you see anything greatest common factor that comes out of the top? And I see that a 4 comes out of the top. So what's left? We've got x squared minus 3. Oh, look at that. X squared minus 3 is on the bottom. I'm going to put parentheses around it so you can see how similar it looks, so you can recognize that you get to cancel them out. All right, and then our answer is 4. We didn't ask about finding the domain, so we're just going to stop there. All right, so the rest of, I've got 2 more examples here. They get harder as we go, so you can just keep watching these if you'd like. You can remember to skim forward, just try each one, and skip to the end where the answer is, and if you didn't get it right, you can back up again, okay? All right, so this one is 18x squared plus 36x plus 10 all over 6x plus 2. All right, so the top, first you want to factor the top, but big clue, ding, 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 that probably is one of the factors. So start with a 6x and see what you can do with it, right? So try that, see if you can figure it out. Pause the video, give it a try. All right, so hopefully you saw that you got 6x plus 2 when you factored this, and 3x plus 5. And that is all over 6x plus 2. All right, so the 6x plus 2 cancels out, and you are left with an answer of 3x plus 5. All right, so the domain, they're asking us about the domain again on this one. So 6x plus 2 cannot equal 0. So this is the domain. All the things that x can be. It's everything but this, all right? So subtract 2 from both sides. You get 6x equals negative 2. Divide by 6. And you get x equals negative 2/6, which is negative, running out of room, negative 1/3. Okay, so x cannot be negative 1/3. Okay, that's the domain. And this is the answer. That's a simplified version. All right, let's try another one. All right, so hopefully you gave this a try. Nope, that's a minus. I almost missed it. So minus 15. So 6x squared plus x minus 15 all over the common denominator of 3x plus 5. All right, so you guessed it. You need to factor it. And again, what do you think your big clue is right there? So probably that is one of the factors. It might not be, but you know, I'm giving you problems that the goal here is to learn how to cancel out the factors. So that's going to be a big clue for you in terms of factoring these. So 3x plus 5 and 2x minus 3 all over 3x plus 5. This is actually another great opportunity to practice factoring. So I would definitely be pausing and trying these. All right, so 3x plus 5 is going to cancel out, and our final answer is 2x minus 3. All right, so pause the video and define the domain. All right, and you should find that the domain is where 3x plus 5 cannot equal 0. So 3x plus cannot equal negative 5. So x cannot equal negative 5/3. And so when you do that, just again, go back and think about, does that make sense? If I put negative 5/3 in right there, I'd end up with negative 5 plus 5 is 0. So yeah, that's the domain. All right, so we are going to review adding rational numbers. So remember, a fraction is a rational number. So to combine fractions, to add or subtract, we must find a common denominator. All right, so I've just got a couple more examples for you, but I just need to explain something first. So we've got to find a common denominator here. So I'm going to show you how I do it, and then I'm going to give you one to try, and you can pause the video and give it a try. So I always think, okay, first, what is the least common denominator of 3 and 4? So the LCD here is 12. So I'm trying to get a 12 on the bottom. So I'm going to rewrite these with long bars. And I'm going to write 1 over 3 plus 3 over 4. Now, why did I do that? So that I can work on giving myself some space here so that I can multiply top and bottom by something to get that common denominator of 12. So I want a 12 on the bottom, so 3 times 4 is 12. I want a 12 on the bottom here, so 4 times 3. And it's not always multiplying by the other one, but so be careful. All right, so we get 4 over 12 plus 9 over 12, and now we get to add those, and we get 13 over 12. Okay, so that would be the final answer. We don't do mixed numbers when we're working with rational expressions. So you try this one. We're going to use this method with rational expressions. So we've got 2 over 3 plus 4 over 5. So what is the least common denominator? And hopefully you see that it's 15. So I'm going to multiply this times 5 top and bottom, and this times 3 top and bottom. And I get 10 over 15 plus 12 over 15. Okay, and that's going to give me 22 over 15. All right, so this portion of it right here, that's what I really want you to be focused on, how we're doing it, because we're going to do the exact same thing with rational expressions. So we're going to add rational numbers with no common denominator. So just like fractions, we need to find a common denominator. So I want you to pause the video and think about what is the common denominator of these two. It was a little tricky. And hopefully you see that the least common denominator is x to the 6th. X to the 6th. Because all I have to do right here, so these are tricky, all I have to do right here is multiply times x over x. And now they're both x to the 6th, and now it's common. Okay, so the least common denominator with exponents is going to be the highest exponent, the highest degree on any of the denominators. Okay, so we end up with what? So try to continue this one all the way to the end. All right, so hopefully you tried it and you got 13x over x to the 6th plus 2 over x to the 6th. So now see how they have a common denominator. So now we get 13x plus 2 over x to the 6th. And that is our final answer. So we have combined them into one and simplified, and there was no reducing to do. All right. So I believe, yep, this is our last one. So give this one a try. All right, so imagine that this was a 3 and a 4. What did we do before? We just multiplied them together, right, and got 12. So we're going to do the same thing here. So the least common denominator is xy. So now that you know that, if you didn't get it, pause the video and try it. All right, so how would I get xy on both of these? So I'm going to multiply the first one by y over y and the second one by x over x. Okay, so I get on the first one, that is this one right here, I get 2y over, and I'm going to put it in alphabetical order, xy, plus, now let's do this one. So this is the first one, plus I get 5x over xy. That is the second one. Okay, so pause the video and think about that if you find that confusing. All right, so now we've got 2y plus 5x over xy. All right, let's write that in a little bit more standard form, which is kind of alphabetical. So 5x plus 2y over xy. And that's our final answer. All right, that was my last example. Thanks for watching.